this lesson we're going to be talking about the Pythagorean Theorem. Now, if we look at the resources that we have available to us as engineers, particularly our FE reference handbook, we actually don't have the Pythagorean Theorem listed directly. So we can see from our FE reference handbook that we're actually given the law of cosines, which looks like this, where this C is the angle opposite from the side C. Now, if this angle C ends up being 90 degrees, as in a right triangle, well, remember, what's the cosine of 90? Well, the cosine of 90 is 0, and if we multiply 0 times negative 2ab, that means this whole term goes to 0, and we're actually left with the Pythagorean theorem, which looks like this. Often when we talk about the Pythagorean theorem, we'll state it as the length C is equal to the square root of the sum of the squares of the other two sides. That's just moving this square root, or this squared term, over to square root on the other side. But this, again, keeping in mind, only applies to right triangles, where this is 90 degrees. Now we can look at a couple of common examples. For example, if we're thinking about the similar triangle, the 3, 4, 5 triangle, we will get, when we plug in those numbers, 5 squared is equal to 3 squared plus 4 squared. So 3 squared is 9, 4 squared is 16. Add them together and you get 25, which is what 5 squared is. We can also find another similar triangle, the 13, 12, 5, which does the same thing. And you can see those in these pictures on these slides, how those graphically work out. So let's put this to work in an example problem connected to actual engineering. Okay, let's look at this example problem dealing with trusses. In statics and in mechanics and materials, you'll learn more about analyzing and designing trusses. But before you can even begin that process, you have to be able to identify the lengths of the members. So in this case, we're looking at a truss who has bays that are 5 meters wide and whose height is 3 meters tall for this particular problem. And we're looking at the length for a particular set of members. Our procedure when we're solving this is to go through and start by sketching the triangle involved. So our sketch will look something like this, where I have the locations on my truss, so A, B, and H, and then I have my dimensions, B, which is 5 meters, and my height, H, which is 3 meters, and I'm looking for this hypotenuse or diagonal dimension, L. We'll notice that when we do this, this comes out to be a 90-degree angle there. Because it's a 90-degree angle, we can write our equation. We can write the Pythagorean theorem. L is my hypotenuse, so L squared is equal to the sum of the squares on the other two sides, so B squared plus H squared. Now we're looking at a one equation where we know both B and H, so all we have to do is solve for that one unknown L. So when we solve this out, we'll start by taking the square root of both sides, like so, and then we'll insert our numbers from our givens. And we'll remember that because we are engineers, we will continue to write our units every single time. When we do this, we'll get the square root of 34 times the square root of meters squared. Now the square root of meters squared is going to give us just meters, so our overall length is equal to 5.83 meters. We'll double check this as a reasonable solution, where we'll see that 5.83 meters is longer than both B and H at 5 and 3 meters. And so our overall answer that we would report would simply be L equal to 5.83 meters. This should set you up for success with your example homework problem, and I look forward to seeing you on campus. Take care.